We're getting ready to hone this cylinder. Before we hone it, we're going to chamfer these ports. That's very, very, very important, especially at the exhaust and at the transfers, because your rings are actually going to flow over these. These are really sharp edges right now. Failure to chamfer these ports is going to result in a ring being snagged. That's the worst case scenario. Best case scenario is just severe ring wear very quickly. And I'll show you how we're going to do this. I'm going to use my Fordham grinder. I picked this up. This is a pretty neat little stone. It's actually a stone dresser. And all I do is just, I can contour my stone any way that I want. And get some fresh material. Next thing to do is to work from the inside of the port out, not the outside in. I'm running about a 10-15 degree angle. I'm just going to put a nice chamfer on these ports. Keep any birds from in there getting snagged up on the piston, and that's it. I'm going to go around and do the whole cylinder. We finished the chamfering of the ports, and this is probably the most important one. Well, it definitely is the most important one. Because this port is wider than everything else, you really need to make sure you've got a nice chamfer in here. The ring is going to have a tendency to try and bulge into this port, and if you have sharp edges, especially in these corners at its widest point, it's just going to destroy your ring. So you really want to pay particular attention, and again, work to the inside of the port and just get a nice chamfer on there. Next thing we're going to do is we're going to hone this cylinder. Before we go ahead and hone this cylinder, I just want to take a minute or two and discuss the different kinds of hones that are laid out here on my bench. This is called a flex hone. What this is, just little pieces of stone on a flexible shaft. This is good for breaking the glaze. Obviously, this is not for a motorcycle. I think this is good for a 4-inch bore. They come in different sizes. They do make them smaller. We don't use flex hones in here, but this is good for breaking the glaze. That's it. This will not remove peaks and valleys. The second hone is available anywhere. I think you could probably even buy this thing at Walmart. I should get paid for plugging them too, but anyway, this is a spring-loaded hone. What this does, you drive it here, has a little piece here you can turn and increase spring pressure, and you can put this into a cylinder, and again, all this is good for is breaking the glaze on a cylinder. You cannot remove material accurately with this hone. If there's any questions, I'll say it again. You cannot remove material accurately with these hones. I'm on a lot of forums. I see a lot of guys doing stuff, and I've actually seen somebody try and bore. The cylinder actually ended up in this shop. He tried to bore a cylinder with one of these, and what a mess. What this does is it just tapers. As soon as you get off the center here and pull this out to get to the top, in essence, you're going to chamfer the top of the cylinder. You cannot hone a cylinder accurately with this. Don't even try. All this is good for is breaking the glaze. That's it. This hone, I believe, is made by Lyle. What this is a positive pressure hone. In other words, there's a little screw at the top. If you watch these stones, I don't know how well you can see this, but as I turn this, these are coming out. This is a smaller version of this. This is a Sudden hone, but it's a smaller version of this, and it's not the quality of this is not even close to this. I do use this in here. I use it for smaller bore cylinders, and it works well. It's accurate. You just have to take your time with it. It consists of 2 stones and 2, these are felt wipers on this one. But this works good. You can buy this. I think they're around $180. I don't remember. I've had it for a long time. But this works good. But this is a positive pressure hone, and you can hone very accurately with this. This is the Mac Daddy. This is the Sonnen hone. What this consists of is 2 stones and 2 aluminum wipers and a cam setup in here. And as you dial the cam, it creates pressure on the inner walls of the cylinder so you can accurately hone it. What we do with this is we'll take 1,000ths at a time and measure it, and very conscientious of temperature. Perfect machining temperature is 68.5 degrees. We like to take infrared readings, whatever. When the temperature goes into the 90s, 100s, I'll stop honing. I'll cool it with coolant, let it sit there for a while, try and get it back to a good stable temperature, and go from there. This is a very, very, very accurate piece of equipment. I will let you in on something. There's power stroke machines out there for doing cylinder honing. I don't own one, and I never will. Those machines are about $20,000 to $30,000. More of an automotive application, and if that's what you're doing, if you're honing 8 cylinders at a time, it's a good thing to do. For motorcycles, I just don't like them. I drive this off of an industrial half-inch drive drill, and we lubricate as we're doing it. And I like the drill setup because I can feel it. I can feel the drill bogging down. I can feel pressure on my arms, and it just allows me to make things very accurate. On a power stroke machine, what you're looking at is you've got a robot moving this up and down inside the cylinder. You set the stroke, moves it up and down, you have a little amps gauge, and you watch the draw on the amps. You can't feel anything, but in my opinion, from what we've done, and I've done thousands and thousands of cylinders in here, this is the most accurate tool for me. May not be the best for you, but it works just as fast. It's a little bit cheaper and allows me to keep my prices down. But this is what we're gonna hone that blaster cylinder with. Got a cylinder out of the honing tank, and what I try to do in here on the cross pattern is 30 degrees. 30 degrees is going to hold a lot more oil. So you 30 and 30, you get a 60-degree angle. I don't like running the 45, 30 degrees on these two strokes. I want these things to hold oil, so that's where we ended up at the 30-degree cross hatch, and that's what it looks like. You can see the chamfer on some of the transfer ports in there. When you get your cylinder back, that's what it should look like. Alright, during the production of this video, we talked a lot about temperature and power hones and accuracy and all this other stuff. And I saw a movie over the weekend. It was called The Outlaw Josie Wales, and he was from Missouri. And he had a line in that movie, and he said, "Show me." I won't go into details, but Missouri is a show me state, so now we're going to show you. I'm sure a lot of you questioned a lot of what I was saying during the production of this video, but now I'm going to show you. This is an infrared heat gauge. I'm going to shoot the top of the cylinder. And then my cameraman zoom in on the readings. We have 68.3 degrees. Again, climate controlled atmosphere. Inside of the cylinder, I'm going to shoot it again. I have 68.3 degrees. Again, perfect machining temperature is 68.5. We're not that good, but 0.2 of 1 degree is nothing that's going to concern me right now. So if everybody's in agreement, our cylinder is acclimated to temperature perfectly. This is the dial bore gauge. I put an arrow on it because I know things are hard to see. 0 is where I want this cylinder to be. Again, honed by hand. And then my cameraman zoom in on the gauge, and that's it. This is the top of the cylinder. I'm going to switch 90 degrees at the top of the cylinder. Going to go to the bottom of the cylinder. Sun and power hone by hand.